Howdy. This short video briefly describes my final video presentation for the project. The project is titled Weekly Sales Prediction of Walmart Stores. This project is held as a competition by Walmart to aid the recruitment process in 2007. The problem statement can be simply put forward as training an agent over the history of the sales figures that depend on specific features so that the agent can predict the future sales without any human involvement given a new input feature vector. The input feature vector is shown here. It has the store number, the department, the number of sales, the date, if the date is a holiday or not, or if it's a special markdown sale like Christmas sale or Thanksgiving sale. Once the input vector is given to the models that are developed based on random forest regression and linear regression, about which I will talk shortly, it gives an output vector that has the prediction of weekly sales. Now, why is this an AI project? Because we are building an intelligent system which undergoes supervised learning, and it's called supervised learning because I'm training the models over the available trained data to make predictions over the test data available. And it builds a representation that can be used for newer predictions, and the representations here in my case are the decision trees. What category does my project fall under? It falls under supervised learning. And I use random forest regression and linear regression as my primary algorithms, and I will use linear regression as a starting point and compare the results with random forest regression. I primarily chose random forest regressions for all the advantages it has for the prediction problems, and few being, it is very versatile. That is, it can be used for regression or classification tasks. Also, it can handle binary features, categorical features, and numerical features with very little pre-processing required. The random forest is also great with high dimensional data since we work with the subsets of the data. Also, the prediction speed is significantly faster than the training speed because we can save generated forests for the future use. Coming to the implementation, I use Python as my primary language to code for the project, and the code is available on GitHub at this repository. The data points is provided by Walmart during the competition, and there are about 115,000 test points and about 420,000 train points, each having 16 features. The toolkits I use for the project are NumPy, Pandas, Matplotlib, and sklearn. All these toolkits help me do all the scientific calculations, the data analysis, the math calculations, and plotting the results. And I do feature engineering as well for this project. That means not all the 16 features available with each data points would be useful in making the prediction. So I find a correlation between these features and try to make or try to tailor new features that can be used to make prediction even better. To evaluate the metrics I use to evaluate the goodness of this project, that is how good the model predicts the outcome or how accurate the model is, I use root mean square error to compare performance of the linear regression and random forest regression. And there is a paper that I have referenced in the end that uses a similar metric, root mean square error, to compare linear regression and random forest regression. I also use confidence matrix prediction accuracy as discussed in the track textbook. The results are as follows. For the evaluation results, the RMSE of the random forest regression is about 3350, and the linear regression RMS error is a bit higher than the random forest regression. And using the confidence matrix prediction accuracy, for random forest regression, the prediction accuracy is about 60.7%, and for the linear regression, it's about 52%. And using the test data, the root mean square error for the random forest regression is about 3416, and for the linear regression, it's about 3772. Again, the linear regression has higher error when compared to the random forest regression. Now, discussing of the results. Now, the random forest regression and the linear regression each have their own benefits and their own deficits. But given the large data set and the number of features each data set has, I would expect random forest regression to work more efficiently than the and the evaluation agrees with this. If you see the numbers for the errors for the random forest regression are lower than the linear regression, and the prediction accuracy is greater than for the random forest regression. And even the test data has higher error than the trained data, so everything agrees. And also the importance of each feature is calculated with respect to the random forest regression. The top 6 features are shown here. The lagged sales, the sales difference, these temperature, fuel price, these have very high effect on the prediction. And here are the references. The book by Dr. Anil Maheshwari has been really helpful for the project, along with the main textbook for the course. And here is the link for the competition, and this is the paper that used RMSE to compare linear regression with random forest regression.